Okay, I'm talking about section 2.1, derivative by the limit method. The derivative of y equals f of x can be written multiple ways. Y prime dy dx, f prime of x. These all mean the derivative. Now, what is a derivative? A derivative is a rate of change. Many people say it's a slope. Well, if it's change in y over change in x, it is slope. Most people know slope as m. Y minus y over x minus x. The change in y over the change in x. In calculus, it becomes dy dx. And yes, it is slope. But what if it was the change in position over the change in time? Then it might be something called velocity. Or the change in velocity over the change in time might be acceleration. So yes, a derivative is a slope if you're applying it to an xy plane. But in reality, a derivative is a rate of change. Sometimes I'll ask that as a bonus. What is a derivative? As long as you say a rate of change, I'm happy. Okay, the derivative can be written like a few ways. Usually you write it f prime of x. And that's going to be equal to the limit as h approaches 0 of f of x plus h minus f of x, the whole thing divided by h. This is called the limit definition of the derivative. We're going to use that extensively. There's also something called the alternate form of the derivative, and that's f prime of c. That gives you the derivative at a very specific value or point. The first one will give me the derivative with letters or variables in the answer. The second one will give me the numeric slope or the numeric rate of change. Let's see, it would be f of x minus f of c, all divided by x minus c. And that's called the alternate form of the derivative. We're also going to be using, or we're going to be finding the equation of tangent lines. To write an equation of a line, you need both the slope, and the slope would be f prime of x, and you need a what? A point. A point is usually x comma y. If we have a point and a slope, I can write the equation of a line using point-slope formula. Y minus a y value is equal to m times x minus the x value. Again, that's called point-slope form, and we use it to write the equations of lines. These are the main formulas we're going to use in section 2.1. Okay, we're going to do 2.1, 13 to 39 odds, 61 to 65 odds in the AP Calculus textbook. And 13 gives us a function. They want us to use the limit method to find the derivative. If you truly understand the derivative is the slope, you might already know the slope of this line is -5. But we need to work through it. If I replace every x with x plus h, if I replace every x with x plus h, what would f of x plus h be? -5x minus 5h. Always use parentheses when you subtract. I want to subtract the original f of x, which is -5x. I believe -5x positive 5x adds to 0. That would leave me with -5h over h. Those h's could cancel. And that would leave me with f prime of x equaling -5. Now, if there was an h to replace with a 0, I might have to do that. But there's your answer for number 13. On 15, I don't like s's. My s's look like 5s. So if you don't mind, I may change them to x's. If you replace every x with x plus h, what would I have? 3 plus 2/3 x plus 2/3 h. Minus, again, always use parentheses. You're going to replace in what the original function was, which was this up here. 3 plus 2/3 h. Cleaning the numerator up, you get 3 and a negative 3, which will add to 0. 2/3 h and a negative 2/3 h, which are going to add to 0. So the only thing left in the numerator is, let's see, 2/3 x. Bear with me a second. Sorry, when I replace my original, it's not 2/3 h. What is my original? 2/3 x, right? So what's going to add to 0 is not going to be what I have adding to 0. It's going to be 2/3 h, and 2/3 x and a negative 2/3 x on the distribution. So the only thing left on top should be this term right here. 2/3 h divided by h tells me that f prime, or the derivative, is 2/3. Again, it was a slope, so you might have known the slope up here was 2/3 also. Now, they're not all going to be linear. That's 13 and 15. You'll notice 17 is a type I would probably ask you. To go from f of x to f of x plus h, you have to replace every x with x plus h. So that's what I'm doing. When you clean this up, you're going to square the first, twice the product, and square the last. That's how you square a binomial. Anyway, that's f of x plus h. We want to subtract the f of x, always use parentheses. What's my original f of x would be x squared plus x minus 3. If done properly, the whole last three terms here should add to 0. X squared and a negative x squared. Negative x and a positive x. Positive 3 and a negative 3. Everything that remains should have an h in it. So I have these three terms remaining. They're all divided by h. So I end up with this. Don't forget that we have to do the limit as h approaches 0. So you're going to put a 0 in for that h. And that will give me my answer, or my derivative, to be 2x plus 1. Okay, 17 was a quadratic. I would ask you that. I probably would not ask a cubic. It's not that hard, but you do have to know how to cube a binomial. So when you replace every x with x plus h, you end up with squaring the first. No, I'm sorry, this is a cube, right? So it would be x cubed plus 3x squared h plus 3xh squared plus h to the third. When you distribute, you'd also have a minus 12x and a minus 12h. all of that you're subtracting the f of x from, or f of x was x cubed minus 12x. Now, if you're having trouble cubing that, just ask me. I can either do it by Pascal's triangle, I can write it out 3 times and distribute it. There are ways of getting that. I just wrote it down, but you have x to the third and a negative x to the third, a negative 12x and a positive 12x. Everything that remains should have an h in it. Now they're all divided by h, so I'm going to divide them individually by h, giving me 3x squared plus 3xh plus h squared minus 12. Now remember, at this point, you're replacing every h with a 0. So those middle 2 terms will go away. That'll be a 0, that'll be a 0. And we find our derivative to be 3x squared minus 12. Again, if you need help cubing the binomial, we could do it using Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. You'll notice those are my coefficients. 1, 3, 3, 1. To get Pascal's triangle, you have to have 1s on the outside. You add the 2 above to get to the next one. So the next line would be 4, 1, 4, 6, 4, 1. And you could extend that as far as you needed. Okay, after 19, I think either give you a radical or a fraction. This one apparently is a fraction. If you were to replace every x with x plus h, I think you'd have this, right? Replace every x with x plus h. Now you're minusing the original. I think we've done a lot of these with conjugates and common denominators. Here's a common denominator one. X plus h minus 1 and x minus 1. X plus h minus 1 times x minus 1. When I multiply on top, what cancels? The trinomial, leaving me the binomial. Minus, again, always use parentheses. When I distribute here, the binomials cancel, leaving me just the trinomial. So I'm going to have x plus h minus 1. On the bottom, you have all of this, x plus h minus 1 and x minus 1. Cleaning the numerator up, I think it just gives you a negative h, because x and a negative x are 0, negative 1, a positive 1 are 0. Now that h could cancel with the h that has a factor in the denominator, leaving me negative 1 over x plus h minus 1 times x minus 1. When I replace the h with a 0, you get negative 1 over x minus 1 times x minus 1, which is x minus 1 squared. And this should be my final answer. Okay, those are the derivative by the limit method. Now we're going to use those to write equations of tangent lines. To write an equation of a tangent line, you need 2 things. You need a point, which I believe I have, and you need the slope. The slope is going to be the derivative at that very specific x value. Once I get a point and a slope, I can fill it into my point slope formula. So, let's find the derivative first. I need to find f of x plus h. That means you're going to replace all the x's with x plus h. When you do this, you square the first, twice the product, square the last, and then minus, always use parentheses again, your original function, the whole thing over h, the limit as h approaches 0. And this will give me what f prime is, which I need for my slope. I already have the point. I just need to find the slope. Anyway, x squared and a negative x squared adds to 0. 3 and a negative 3 add to 0. 2xh plus h cubed, they're both divided by h. You're absolutely right. This should not be h cubed. The square the first, twice the product, square the last should be h squared, right? So leaving me this. So when I replace the h with a 0, you're going to get 2x plus 0. So f prime of x is 2x. I need f prime at what x value? Whatever point we're speaking about. So I need it at the x value of -1. So that makes my slope -2. So basically, we find the derivative using the limit method. We put in the x value to get the slope. Now I'm just going to fill into my equation y minus the y value equals the slope times x minus the x value. My xy point, y value is 4, the x value is -1, and we just found the slope to be -2. So that makes y minus 4 equal -2x, I think -2 when you distribute. And then when you add the 4 over, because I will ask for it in slope-intercept form, you get y to equal -2x plus 2. And that's the equation of the tangent line. Let me show you visually what that means. Okay, we have a curve, x squared plus 3. That's what we're talking about. We have the point -1, 4. The point -1, 4 is over here somewhere. If I was to draw the tangent line, should I expect a positive or negative slope? Hopefully a negative slope. And I believe the y-intercept would have been 2 if I'd done it accurately. Okay, 27 is another one. If I was to do the derivative, I think we would find that the derivative, eventually you're going to hear me say things like power. What's the power? 3 times the base to the 1 less power. And that's kind of part of the shortcut to finding the derivative of polynomials. Power base, 1 less power. If we were to put in an x value that we're given of 2, does that mean that my slope would be 12? That's if you knew that was a derivative, right? So anyway, we'll replace x with x plus h. So that would be x plus h cubed, right? And so that becomes x cubed plus 3x squared h plus 3xh squared plus h to the third minus the original function all over h, the limit as h approaches 0. Now x cubed and negative x cubed would add to 0, leaving me 3x squared h plus 3xh squared plus h to the third. They're all divided by h. Gives me 3x squared plus 3xh plus h squared. Again, we're going to replace all the h's with zeros. So that means that my function is f prime, that is 3x squared plus 0 plus 0, or 3x squared. Put the 2 in, it'll give you the slope of 12. So I now have my point, which is 2, 8, and my slope, which is 12. Y minus the y value is equal to m times x minus the x value. Let's plug everything in. The y value is 8, the x value is 2, and we just found out the slope was 12. So y minus 8 equals 12x minus 24. Add the 8. And I hopefully end up with y equals 12x minus, is it 16? And that should be the equation of the tangent line at that point. Okay, after 27, that's another tangent line question. Looks like we have another tangent line. We did a fraction, so this one is a radical. If I replace x with x plus h, I would have this minus the original function all over h. Remember, you're doing the limit as h approaches 0, because this is the derivative, right? Anyway, this gives me 0 over 0. So the conjugate of a minus b is going to equal a plus b. When you multiply them, you get a squared minus b squared. So the conjugate really just changes the middle sign. So instead of radical minus the radical, the conjugate is a radical plus the radical. Now when you multiply these and you end up with a squared minus b squared, this is a, so a squared is x plus h. Always use parentheses. If this is b, what's b squared? X. Simplifying the top, you just get h. Yeah, the top you have x minus x adds to 0, leaving you just h. Don't forget you have all this stuff on the bottom, though, or in the denominator. So you have h times radical x plus h plus radical x. I think these h's could divide out. Don't forget there's a 1 in the numerator. What do I have? Plus radical x. Now you need to make the h become a 0. So you're going to replace every h with a 0. So you have radical x plus radical x, which is 2 radical x. That's what the derivative is going to be. And I put in the x value that they give me. The x value here, x, y. The x value is 1. So I think that's going to make the slope of the tangent line 1/2. So I have a point, 1, 1. And I have a slope. So now I'm going to fill it into y minus the y value equals m times x minus the x value. Point slope, because I have a point and a slope. So y minus the y value is 1, the x value is 1, and we know the slope is 1/2. So I get y minus 1 equals 1/2 x minus 1/2. If I distribute, add the 1 is the same as adding 2 halves. So I think you get 1/2 x plus 1/2, or y equals that for the tangent line equation. I believe the next one's going to give you a graph of a function and ask you to sketch what the graph of the derivative might look like. So they give me this. Please remember that the derivative is the value of the slope. What is the slope here, positive or negative? Negative. What is it here? Negative, but less negative, right? So you got negative, 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 negative. But what happens right at 4? What's the slope? 0. So if I'm graphing the derivative, it has to have a 0 right there. It's negative, and then what does it become over here to the right? What are these slopes? Positive, more positive, more positive. So the actual derivative is could look like this. That could be f prime. Now there's multiple ways. Well, it has to be 0 at 4, and it has to go from negative to positive at 4, because that's what the curve does. These can be tricky. Now I think the next one is an alternate form of the derivative. They give us this. The alternate form of the derivative gives me f prime of c is equal to the limit as x approaches c of f of x minus f of c all over x minus c. So I'm going to fill into this formula. I have the limit as x approaches. On bottom I have x minus and f of c. Okay, so we're going to fill everything in now. Do we know what f of x is? So I'll fill that in. Do I know what c is? So I fill that in 2 spots there. Can anybody tell me what f of c is? F of c. You'd replace the c with the 3, and I think f of 3, or f of c, would be 4. So I put a 4 here. That makes this x squared minus 9 over x minus 3 as x approaches 3. The top could factor to x plus and x minus 3 as the difference of squares. These could divide out, giving me the limit as x approaches 3 of x plus 3. 3 plus 3 makes f prime of the c value, f prime of 3 should equal 6. That's called the alternate form of the derivative. I told you if you're doing the alternate form, you're going to end up with a numeric answer. Whereas when we did it with the limit method back here, we had x's in the answer. It was not numeric like 61. Anyway, I hope these help. Good luck.